Hello everyone, welcome to solve this math Olympiad algebra problem, and here we have 3 to the power of x plus 2 to the power of x equals to 25, and we solve this problem for the values of x. So here you remember one thing is that our x is must be an integer. Okay, so we solve this problem for the integer values. So that here the very first thing we are going to do is here first we multiply and divide the exponent of both of these terms by 3, so that it will be written as 3 to the power of x and its whole power 3 over 3, and plus we write this term as 2 to the power of x and its whole power 3 over 3 is equals to 35. And now in the next step, here we use the nice exponential law, and according to this exponential law, we write this term as 3 to the power of x over 3 and its whole cubed, plus here we write this term as 2 to the power of x over 3 and its whole cubed equals to 35. And now in the next step, here we just convert this exponential equation into the simple or cubic form, so that here we just take a equals to 3 to the power of x over 3, and we take b equals to 2 to the power of x over 3. So here you see that our a and b are exponential function, and we know that exponential function always gives us the positive value, so that here we just say that our a and b must be an positive integer. Okay, and a and b is not equals to 1, so this is the condition on this a and b. And now we substitute these two values on above equation, so that our above equation will be written as a cubed plus b cubed equals to 35. And now here we use the nice cubic formula in the left hand side, and we know that a cube plus b cube is equals to a plus b times of a square minus ab plus b square, and this is equals to 35. So here you focus in the left hand side, and you see that we have two factors are multiplied by each other, but in the right hand side we have only one factor. So here we just find the possibilities in which you get the product of two numbers is equals to 35. So we have the possibilities are 1 times of 35 is equals to 35, and the second possibility is 35 times of 1 is also 35, and 5 times of 7 is 35, and 7 times of 5 is 35. So here we have these four possibilities in which we get the product of two numbers is equals to 35. But here you remember one thing, you remember the relation between these two factors is that our first factor, which is a plus b, is always less than a square minus ab plus b square. So this relation is always hold on these two pairs. So here we just choose those pairs whose satisfied this relation. So if you see here, the first term is less than second term, so it means that this is hold. And here you see that 35 is greater than 1, but the first term is not less than second, so it cannot be hold. We cannot choose this. Here you see that 5 is less than 7, so that we choose this, and 7 is greater than 5, so we cannot choose this. So here we have two possibilities which hold this condition, so that we just compare the left hand side with these two possibilities, and here we have the two cases. So here we make two cases. Our first case is we compare these two values on this, and second case is we compare these two values on this. Okay, so here we make two cases. Our first case is we just write our a plus b equals to 1, and the second possibility is we have a square minus ab plus b square equals to 35. So this is the our case number 1. And our case number 2 is, in this case we compare this value on these terms, so that here we get a plus b is equals to 5, and a square minus ab plus b square equals to 7. So here we have these two cases and we can solve these two cases. So here first we focus on case number 1, and here we just write from case 1. So in case number 1, we take the square on this term. So when we take the square on this term, on both of the sides it will be written as a square plus 2ab plus b square equals to 1. So here we call this is equation number 1, and we call this is our equation number 2, and this is equation number 3, and this is our equation number 4. So here we just solve equation number 1 and 4. So first we just write here our equation number 4. So our equation number 4 is a square plus 2ab plus b square equals to 1. This is equation number 4, and equation number 1 is a square minus ab plus b square equals to 35. So here we solve these two values, and now here when we subtract these two equations, it will be written in this form. So this is cancelled by each other, this is also cancelled by each other, and we get here 3 times of ab equals to minus 34, and we just obtain our ab equals to minus 34 over 3. So this shows that the product of a and b is some negative number. So also it is not an integer, but here we make the condition on ab is that our a and b must be an positive integer. So if a and b are positive integer, so this implies that the product of ab is also the positive integer. So this cannot hold this condition, so that we rejected this case, and we can proceed here over case number 2. So from case number 2, here we just write our case number 2. So in second case we have the value of a plus b is equals to 5, and the second equation is a square minus ab plus b square equals to 7. So this is our second case, and now here first we focus on this equation, and here we move this b to the right hand side, and we have a equals to 5 minus b, and we call this is equation number 5. So here we substitute this equation number 5 in this equation. So it will be written as a square, so our a is 5 minus b square minus a is 5 minus b into b plus b square equals to 7. So here we just open the square of this term, and it will be written as 25 plus b square minus 10b, and minus we have 5b plus b square plus b square equals to 7. So here we add we simplify these terms, and we get 3 times of b square minus 15 times of b, and here we move this 7 in the left hand side, and 25 minus 7 is equals to plus 18, and this whole equals to 0. So here we divide each of these terms by 3, and we get here b square minus 5b plus 6 equals to 0. And now we make the pairs of this equation, and its factors are written in this form: b square minus 5b b square minus 3b minus 2b plus 6 equals to 0. So that here we take common b from first two terms, and we get here b minus 3. Here we take common minus 2, and we get b minus 3 equals to 0. So here we take common b minus 3 from both of these terms, and we get here b minus 2 equals to 0. So we have b minus 3 equals to 0 and b minus 2 equals to 0. So in this case we get b equals to 3, and here we get b equals to 2. So these are the two values of a and b. Also you see here these two values are integer values. So now we substitute these values of a and b in equation number 5. This equation we have a equals to 5 minus b, and so here we just our equation number 5 implies that a equals to 5 minus b, and here we substitute these two values here and we get a equals to 5 minus 3, and when we put this value here we get a equals to 5 minus 2. So after simplification we get the value of a equals to 2, and here we get the value of a equals to 3. So now we have the value of a is 2 and value of a is 3. So here we back substitute the values of a and b, and you see here we have our a equals to 3 to the power of x over 3 and b equals to 2 to the power of x over 3. So we substitute these two values here. So we have this is 3 to the power of x over 3 equals to 2, and in this case we have 3 to the power of x over 3 equals to 3. So here this is not possible because here we find the integer solution. It cannot gives us the integer solution, so that we rejected this case. And here you compare both of the sides and you easily get the value of x over 3 equals to 1, and here you get the value of x equals to 3. This is our final answer of this question, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.